This is a single phase AC circuit. Single phase voltage is applied here, and this is a load. This load is giving power equal to VI cos phi. This cos phi is a power factor, VI is a kVA of the supply. Okay, what if we need more power? We have to connect more windings in the circuit. Yes, more windings in the circuit. We can call that more phases in the circuit. And that's why there is a concept of three phase. We can have multi phases, but the best suitable combination is a three phase circuit. So what does it mean? Three phase circuit means we have three different windings, or we have three different phases. Now if we connect these three different phases to the source, we have to have 6 wires here. And to avoid these wires, to reduce the connection, we can convert these three phases into some suitable connection. Right now we are talking of star connection. In the star connection, what is done is end of each winding, let us say this is another winding, is connected together, and only three wires are taken out. These three wires are given some color coding like red, yellow, blue, and this is your now load. Okay, so in the load, these three windings are connected in such a way that they form star connection. It is also called as a Y connection. Y connection. Okay, now there is a reduction of three wires here. Instead of taking 6 wires, we can have only 3 connections here. This is called as a star connected three phase load. Okay, now in the star connected three phase load, let us understand the quantities here. Let us say this is a red phase, this is yellow phase, this is blue phase, and it is connected to, let us give the name R. It is connected to source and give the name RYB. Okay, so this is R Y B. Let us name this point as a neutral point. Now this R to N is called as a phase, like similarly Y to N, B to N, and the voltage here from R to N, we call it as a phase voltage. Similarly, you can see here Y to N, that is also a phase voltage, and similarly here B to N, that is also a phase voltage. This voltage is in the load, is in that winding. But look at this. This is a red line and this is a yellow line. The voltage between red line and yellow line is called as a line voltage. We can name it as a VRY. It is a voltage between line to line, red line and yellow line. Similarly, there is a voltage between yellow line and blue line, that is also a line voltage. Similarly, there is a voltage between blue line and red line, that is also a line voltage. Line voltage means line to line voltage. And the current flowing here, you can name this as a line current. Here, yellow current, yellow line current. This is a blue line current. Okay, but this current is entering into the winding, it is entering into the load, it becomes phase current here. The current from R to N, we can call it as a phase current. Current from Y to N, we can call it as a phase current from Y to N. Similarly, there is a current from B to N, we can call that as a phase current. Okay, so I can write IRN, IYN, IBN, these are the phase currents. VRN, VYN, VBN, these are the phase voltages. VRY, VYB, VBR, these are the line voltages, and you can call it as a IR, IY, yes or no, IB, we have already called it. Okay, these are the line quantities. Okay, so these three are line quantities, line current. This is IR, this is line current. Okay, this is also a line current. So IR, IY and IB, these three are line currents. Okay, so by observation we can say that line current, the same line current is entering into the phase. So by observation I can say line current is equal to phase current by observation. Okay, line current is equal to phase current. What about line voltage and phase voltage? What is the relation between line voltage and phase voltage? Let us consider one line voltage here, that is voltage from red line to yellow line. I am removing third winding here to understand the relation between phase voltage and line voltage. This is now a complete circuit. By Kirchhoff's law, I can write VRY, this voltage, is equal to sum of VRN plus VNY. VRN, this is phasor addition. VRY is equal to VRN plus VNY. But you can observe here, this in this yellow phase current is going from Y to N. So that's why instead of writing VNY, I have to write minus VYN. Okay, and if I draw phasor diagram of this concept, let us say this is red phase voltage, this is yellow phase voltage, this is blue phase voltage. These three voltages are 120 degree apart: red phase, yellow phase, blue phase. They are having 120 degree angle. Okay, so let us draw this. VRY is a combination of VRN minus VYN. So we already have VRN here, minus VYN I am taking on negative side. This is minus VYN. Now VRY is a resultant of VRN and minus VYN. If I combine these together, if I draw a parallelogram over here, I will get resultant voltage value here. This is VRY, voltage between R and Y, and this angle is a 30 degree over here. So we can say that line voltage and phase voltage, it is not same here. Line voltage and phase voltage is not same here, and if I do some mathematical calculations here, I can prove that this line voltage is equal to √3 times phase voltage. Okay, so in star connection, line voltage is equal to √3 times phase voltage. Let us prove that. Let us draw one line here. Name this, let us say this is OMN Okay, let us say this is P. So you can see here, this is 90 degree, this is 60 degree. We can write here ON is equal to root 3 by 2 into OM. Okay, ON is equal to root 3 by 2 into OM, and OP is equal to 2 times ON. It means OP is equal to 2 times root 3 by 2 OM. Because this ONM is a 30, 60 and 90 degree angle, so ON is equal to root 3 by 2 times OM. So this 2 will get cancelled. OP is equal to root 3 times OM. What is this OP? OP is a line voltage. That is equal to root 3 times what is OM? That is a phase voltage. Yes, so we have proved here line voltage here is root 3 times of the phase voltage. So in star connection, line current is equal to phase current, line voltage is equal to phase voltage. Okay, so whenever you are solving any numerical based upon star connection, you have to remember these two formulae. Okay.